Hi everyone. In this video, we are going to look at a limiting reactant stoichiometry problem. We can see the problem is asking us if we have 30.25 grams of glucose reacting with 6.93 grams of oxygen gas. CO2 and H2O are produced. How many grams of H2O are formed? First things first, we need to write out the actual chemical equation. In this case, we're going to take glucose, which is C6H12O6, plus O2 yields CO2 plus H2O. Now, as we know, we need to make sure that we balance this equation before we do any type of stoichiometry mathematics with it. If we don't have a balanced equation, then it does not obey the law of conservation of mass, and we need that to happen. So I like to start off with my carbons. I don't start off with the oxygens because they are all by themselves and it gets confusing. I'll put a 6 in front of CO2 to make sure I have 6 carbons on both sides. I have 12 hydrogens on the left, so I'll put a 6 in front of H2O to make sure I have the same number on the right. I have 6, 7, 8 oxygens on the left, and I have 12, 18 on the right. So in order for me to have 18 on the left, all I've got to do is add up my 6 and 12 more. So I'll put a 6 in front of the O2. And everything looks balanced now. I have 6 carbons, 12 hydrogens, and 18 oxygens on both sides. So now we can get going. Once we have this balanced chemical equation, our problem gets a little bit more simple now. We're going to take a look at our reactants, and we're going to figure out which one is considered the limiting reactant. Now, the limiting reactant is the one that controls how much of your products are formed. So we got to figure out which of these, glucose or oxygen gas, are our limiting reactants. And all we know is that we have 30.25 grams of glucose and 6.93 grams of oxygen. So how can we determine the limiting reactant? The first step that we need to take is to make sure we calculate the moles of each substance. Grams is not going to help us. So in order to get grams converted to moles, we need our molar masses. So let's figure out what it is for glucose. Now, since the formula is C6H12O6, I'm going to multiply carbon's molar mass from the periodic table by 6. I will multiply hydrogen's molar mass from the periodic table by 12. And I'll take oxygen's molar mass and I'll multiply it by 6 as well. Once I've done all this, I'm going to add them all together. And my total molar mass for glucose ends up being 180.156 grams per mole. So that is our molar mass for glucose, which will help us determine the number of moles that we have. We also need to figure out the molar mass of oxygen gas, O2. This is a little bit more simple than glucose because we only have 2 atoms involved and they're both oxygen. So we will just take 2 times 15.999 grams per mole, oxygen's molar mass, to get our answer of 31.998 grams per mole of O2. Now that we have our molar masses, we can move forward to our mole calculation. So converting grams to moles. And first one that we're going to do is figure out how many moles of glucose we have. Here's how I like to do it. I like to take my grams, 30.25, make sure I label it grams, and I label my substance as well with glucose. And I'll put that over 1 just to get it into fraction form. That makes this part a little bit easier. I'm going to make sure that I have grams of glucose on the bottom and moles of glucose on the top. This helps me put my my molar mass in the correct location and ensures that I'm not multiplying when I divide or when I should be dividing, or not dividing when I should be multiplying. So we got our 180.156 grams in our denominator. The units of those cancel out, and I could just multiply straight across this fraction to get my new answer. And I get that the moles of glucose in this problem are 0.1679. And, oh, sorry, not grams. Let's get rid of that. It's moles. So I've gotten the moles of my first substance. I now need to figure out how many moles of my second substance we have, because we need to compare them. So I'm going to do the same exact thing. I take my mass of oxygen, put it over 1 so it's in fraction form, and then I'm going to multiply it by the inverse of the molar mass. Put 31.998 grams of O2 on the bottom, 1 mole of O2 up top, so that units cancel. And then I do my math. When you plug that into the calculator, you end up with another small number, 0.2166 moles. So we have more moles of oxygen than we do of glucose. Does this tell me what my limiting reactant is? No, not really. In order to determine my limiting reactant, I have to figure out what the ratio or the molar ratio is between oxygen and glucose. It has a lot to do with the balanced chemical equation. If we take a look at the chemical equation, we have 6 oxygens for every 1 glucose. Let me just rewrite the equation here and you can see what I'm talking about. Based off of the coefficients in this equation, the molar ratio of glucose to oxygen is 1 to 6, right? So if I look at our moles that we have calculated, which I will rewrite down right now, 0.1679 moles, and then my moles of oxygen is 0.2166 moles. The balanced equation tells me for every 1 mole of glucose that I have, I should have 6 moles of oxygen to react with it. Looking at the actual number of moles that I calculated in this problem, it doesn't seem like for every 1 mole of glucose, that'll have 6 moles of oxygen. So I'm going to set up a mole ratio. 6 moles of oxygen for every 1 mole of glucose. I'm going to put it like this in a fraction form. And basically, I'm going to use this mole ratio between the two substances to figure out which one of my reactants ends up being the limiting reactant. And the way I'm going to do this is I'm going to convert my moles of glucose into moles of oxygen. If I do this, my answer should be the number of moles of oxygen that will react with 0.1679 moles of glucose. Okay, so once again, I'm going to take my actual number of moles of glucose and convert it using the molar ratio of glucose to oxygen into moles of oxygen. And that will tell me how many moles of oxygen are needed to react with that many 0.1679 moles of glucose. And then we'll see if I have more or less than that. If I have more of my oxygen than is needed, then our limiting reactant will end up being the glucose. But if I have less oxygen than what is needed to react with the 0.1679 moles of glucose, then oxygen is my limiting reactant. And we see that for every 0.1679 moles of glucose, I would need 1.007 moles of oxygen to react with it. Do I have that? Not even close. I only have 0.2166 moles of oxygen. So once again, I'm going to label this the moles of oxygen needed to react with the 30.25 grams of glucose. This is how much we need, but we don't have that. Instead, we only have 0.2166. So this will make oxygen our limiting reactant. And what does that mean? That means that all of our mathematical solutions that we come up with are going to be based off of our quantity of oxygen. We have excess glucose. We do not have excess oxygen. So if we base our calculations off of the moles of oxygen, we will get the amount of products that we're supposed to form. If we base our stoichiometry calculations off of the moles of glucose, we will get a overestimate of the products that will be formed. So we're going to pretend like that 30.25 grams or that 0.1679 moles of glucose doesn't exist. We're going to pretend that the problem didn't even tell us how much glucose we have. We're just going to imagine that all it said is that we have that 6.93 grams of oxygen. And we're going to use that in order to figure out the grams of H2O formed. And from here on, it's a basic stoichiometry problem, right? We're going to start with our moles of oxygen, and we're just going to multiply by mole ratio in order to convert that to water, whatever it's asking for. I believe the question asked about water, right? So I take that 0.2166 moles of oxygen, and I'm going to put the 6 moles of O2 from our balanced chemical equation down below, and I'm going to compare that to the number of moles of water in the equation. And they both have a coefficient of 6. So really, all I'm going to get is I have the same number of moles of water as I do of oxygen. But in order to figure out how many grams of water that is, I'm going to need to multiply by water's molar mass, which happens to be 18.015 grams of water for every 1 mole of water. All of my units end up canceling. And when I plug this into the calculator, it's really going to simplify to 0.2166 times 18.015 because our 6's simplify to just a 1. My answer ends up being 3.902 grams of water. And that is how you do a simple stoichiometry problem. Please subscribe to my YouTube channel and TikTok at Mr.CavScience for more chemistry related content.